So here's just a little recap on how we present data in tables and how we use units in tables. So here I have a table with just some enthalpy of formation and entropy of formation and Gibbs energy of formation data. And so we can see here where I have this enthalpy of formation column here, it's presented as the enthalpy of formation delta HF with my standard state, and then we have that divide sign before I have my unit, kilojoules per mole. And essentially, if I just take this data here for the copper oxide, what it is saying is delta HF standard divided by kilojoules per mole is equal to minus 167. Or if I rearrange that to just give me my value for delta HF standard state is equal to minus 167 kilojoules per mole. So I've just rearranged that by multiplying both sides. Now, the reason we present the data this way is basically because I just have a number in my table, and by presenting it as my value divided by my unit, that allows me to present just a number. And so for any of these other values, whether it's heat capacity or delta G, I can always just think of it that way, that my value divided by my unit is just a number, so my number multiplied by that unit gives me my value. Here on this page, I've got the correct formatting of how we present data with a power of 10 presented into it. So this is just some kinetic data showing me the concentration of this acetate ion. And here, if I just pick this column here, or this row, sorry, here, I can see that when the time is 300 seconds, in other words, T divided by S is equal to 300, and therefore T is equal to 300 seconds. I can see that this value here, the concentration of CH3COO minus, divided by 10 to the minus 3 moles per decimeter cubed, is equal to 23.04. So now I can rearrange this to find that my concentration of acetate ions is equal to 23.04 times 10 to the minus 3 moles dm cubed, or that would be the same as me writing 0.02304 moles per decimeter cubed. Now, usually what people want to do is they want to present the times 10 to the minus 3 on the top of this. So it would be concentration of acetate times 10 to the minus 3 to present it that way. But if you're going to present it on the top, so if I just kind of make my table here, in this case, this would be 10 to the plus 3 per moles decimeter cubed. So I think it's 23.04 when I've got 300, so there's a bit of information before that. So now you see, I have this case where I've got plus 3. Why is it plus 3 if it's on the top? Well, if I think of this as CH3COO minus times 10 to the plus 3 divided by moles per decimeter cubed is equal to 23.04. Then when I want to rearrange that, that means that CH3COO minus, I'm just going to rearrange it's 2 steps at once. So I'm going to divide both sides by 10 to the plus 3, so that becomes 10 to the minus 3 on this side, 23.04 times 10 to the minus 3 here, and then moles per decimeter cubed. This is often the opposite way around to how people want to do it, but this is how data is presented in a scientific context.